Assalamualaikum and hi everyone. Today we're going to look at our fifth lecture, Quantitative Research Methods. Recall from our first video lecture that social science research can mainly be divided into basic research and applied research. Basic research is when you focus on the creation of knowledge or theory, whereas applied research is when you focus on finding solutions to a practical problem. Both types of research complement each other. Applied research will use theories obtained from basic research, whereas basic research depends on the results of applied research in constructing complete theory. Both basic research and applied research can be undertaken by using either a quantitative, qualitative, or even mixed approach. We have also seen in the first video lecture how one's paradigm influences the way a person conducts research. A researcher may adopt a quantitative approach or a qualitative approach. Some may even adopt a mixed approach, although we have seen previously that this is quite seldom, as it requires a deep understanding and knowledge of both approaches. In this video lecture, we will be focusing on the quantitative research methods. Quantitative research is research that uses quantitative data, problems, phenomena, or variables. In quantitative research, we will approach various information in numerical form. The type of variables that we use heavily depends on the approach we take. For quantitative research, our variables can be measured numerically and can further be divided into discrete or continuous variables. Discrete variables are those that can take only certain values, such as the number of people queuing up at the ATM or the number of cars parked by the roadside, while continuous variables can take any value within a specified range, such as the household monthly expenditure, time, weight, and height. There are many advantages to using quantitative research methods in social science research. The most important strength of quantitative research is that it is more reliable and has greater objectivity. Quantitative methods presume to have an objective approach to studying research problems, where data is controlled and measured to address the accumulation of facts and to determine the causes of behavior. As a consequence, the results of quantitative research may be statistically significant. Quantitative research allows a broader study to be made, involving a greater number of subjects or larger sample sizes, which enable the results and findings to be generalized. Quantitative research often reduces and restructures a complex problem to a limited number of variables. This is because generally, quantitative methods are designed to provide summaries of data that support generalizations about the phenomenon under study. In order to do so, quantitative research usually involves few variables and many cases and employs prescribed procedures to ensure validity and reliability. Quantitative research applies well-established standards, which means that the research can be replicated and then analyzed and compared with similar studies. Besides that, you can summarize vast sources of information and make comparisons across categories and over time. Personal biases can also be avoided in quantitative research by keeping a distance from participating subjects and using accepted computational techniques. Quantitative research looks at relationships between variables and can establish cause and effect in highly controlled or uncontrolled circumstances. And last but not least, quantitative research also enables us to test theories or hypotheses. Despite its many strengths, quantitative research methods are not without limitations. Some of the limitations with using quantitative methods to study research problems in the social sciences is that, while quantitative data is more efficient and able to test hypotheses, they may miss contextual details and provide less information on behavior, attitudes, and motivation. The static and rigid approach of quantitative research may cause an inflexible process of discovery. The development of standard questions by researchers may lead to structural bias and false representation, where the data actually reflects the view of the researcher instead of the participating subjects. Results from quantitative research may be limited, as they provide numerical descriptions rather than detailed narrative and generally provide less elaborate accounts of human perception. research is often carried out in an unnatural, artificial environment so that a level of control can be applied to the exercise. This level of control might not normally be in place in the real world, thus yielding laboratory results as opposed to real-world results. Preset answers will not necessarily reflect how people really feel about a subject, and in some cases might just be the closest match to the preconceived hypothesis. There are many types of quantitative research that you can use, depending on your field of study. It might be easier to understand the different quantitative approaches to research if you consider how the researcher designs for control of the variables in the investigation. Say we view quantitative design as a continuum. One end of the range represents a design where the variables are not controlled at all and only observed, and the connections among the variables are only described. At the other end of the spectrum, however, are designs which include a very close control of variables, and relationships among those variables are clearly established. In the middle is a range which blends those two extremes together. From this illustration, we can identify four main types of quantitative research: descriptive, correlational, quasi-experimental, and experimental research. Descriptive research seeks to only describe the current status of an identified variable. These research projects are designed to provide systematic information about a phenomenon. But oftentimes, researchers may want to do more than just describe, and so correlational studies come into the picture. Here, researchers attempt to determine the extent of a relationship between two or more variables using statistical data, while still conducted in a natural setting. This type of research will recognize trends and patterns in the data, but it does not go so far in its analysis to prove causes for those observed patterns. A quasi-experimental study, or also known as a causal comparative study, goes a notch further and used by researchers to examine the cause-effect relationships between two or more variables in a natural setting. This study is often used in economics, finance, and various medical studies or medicine where it is difficult to have full control of the population. And finally, we have experimental research, which is normally used in the natural sciences. They use the scientific method to establish the cause-effect relationship among the group of variables. While true experimentation is often a laboratory study, it can also be any study where an effort is made to identify and impose control over all other variables except one. Depending on the type of quantitative research design that you choose, it will greatly affect the way you present your proposal. And whichever type of quantitative research that you opt for, they are all data-oriented. So one way is to use secondary data, and the other is collecting your own primary data. Here is an outline of the research methodology chapter in your proposal. On the left is the general outline if you are running regressions using secondary datasets. And on the right is the general outline if you are collecting primary data via surveys. In this video lecture, we will focus on the methodology of using secondary data, as the latter will be covered in more detail in upcoming video lectures. Before going into the details of the research methodology chapter, you might want to know the purpose of having a research methodology chapter in your thesis as well as your proposal. This chapter is designed to show how you intend to answer your research question using specific theories or models and empirical analysis. The goal is to provide a clear and complete description of the specific steps that you intend to follow. It is absolutely necessary to describe these steps in sufficient detail to permit a naive reader to replicate your study. So how do we begin the chapter? A reasonable way to begin a methodology chapter is to develop an introductory paragraph that describes both the design of the study and organization of the chapter. This prepares the reader for what is to follow and provides a framework within which to incorporate all of your materials. It is absolutely essential for one to know about econometrics if you are planning to use a quantitative approach. Econometric analysis are widely applied, and not only in economics, but finance and other fields of social science. Simply stated, econometrics means economic measurement. It is the application of statistical methods, mathematics, and more recently, computer science to economic data, and is described as the branch of economics that aims to give empirical content to economic relationships. The first use of the term in cognate form was by Polish economist Paweł Ciąpa in 1910, who at the time conceived econometrics as being entirely descriptive. But it was Norwegian economist Ragnar Frisch who was widely credited for coining the term econometrics and for establishing it as a subject in the sense it is known today. He is also one of the founders of the Econometric Society and its journal Econometrica. In fact, both he and Jen Tinbergen won the Nobel Prize in 1969 for having developed and applied dynamic models for the analysis of economic processes. Here are several popular definitions of econometrics. The main uses of econometric analysis or econometric modeling are to estimate economic relationships, to explain variations in key variables of interest, to make predictions or forecasts, for theory validation or testing economic theories, for the development of new theories, and for policy evaluation. So what makes a good econometric model? Here are the essential ingredients. Your model basically needs to have a strong theoretical foundation and have both the elements of math and statistics to reflect that theory. You also need to apply your own intuition when explaining the results of your regression analysis. How does one actually do an econometric study? Broadly speaking, econometric analysis proceeds along the following steps. The starting point is to create a statement of theory or hypothesis, that is, find out what theory has to say on the subject you want to study. We then go on to collecting data. We then specify the mathematical and econometric model of the theory, estimate the parameters of the chosen econometric model, and check for the model adequacy. We also test the hypothesis derived from theory by running regressions. All this fall under model specification. Researchers also need to apply diagnostic tests to check on the robustness of their model. And finally, we use the model for prediction or forecasting. As you can see, the steps in econometric analysis overlaps with the general structure of the research methodology chapter. This may actually be helpful for you because as you complete the econometric process, you will have completed your research methodology chapter. To illustrate how you conduct this entire econometric analysis, let's take a look at a comprehensive example. Say you're interested in the following question. Do economic conditions affect people's decisions to enter the labor force, that is, their willingness to work? So to start, we need to find out what economic theory has to say about the subject we want to study. In labor economics, there are two rival hypotheses about the effect of economic conditions on people's willingness to work. The discouraged worker hypothesis states that when economic conditions worsen, as reflected in a higher unemployment rate, many unemployed workers give up hope of finding a job and drop out of the labor force. On the other hand, the added worker hypothesis maintains that when economic conditions worsen, many secondary workers who are not currently in the labor market, for instance, mothers with children, they may decide to join the labor force if the main breadwinner of the family loses his job. Even if the jobs these secondary workers get are low-paying, the earnings will make up some of the losses in income suffered by the primary breadwinner. Whether on balance, the labor force participation rate will increase or decrease will depend on the relative strengths of the added worker and discouraged worker effects. If the added worker effect dominates, the labor force participation rate will increase, even when the unemployment rate is high. In contrast, if the discouraged worker effect dominates, the labor force participation rate will decrease. We have identified two main variables from our question. One, economic condition, and two, people's willingness to work. For empirical reasons, we need quantitative information on the two variables. Suppose we use the unemployment rate, UNR, as a measure of economic conditions, and we use the labor force participation rate, LFPR, as a measure of labor force participation. Data on both UNR and LFPR are regularly published by the government. So we proceed with collecting the data on the right, which is data on the civilian labor force participation rate and the civilian unemployment rate, defined as the number of civilians unemployed as a percentage of the civilian labor force for the United States for the period 1980 to 2007. As you have seen before, there are multiple aspects of model specification. We will look at them one by one here. To see how the civilian labor force participation rate behaves in relation to the civilian unemployment rate, the first thing we need to do is to plot the data for these variables in a scatter diagram or scattergram. The scattergram shows that CLFPR and CUNR are inversely related to one another, perhaps suggesting that, on balance, the discouraged worker effect is stronger than the added worker effect. As a first approximation, we can draw a straight line through the scatter points. We can then write the relationship between the two variables by the simple mathematical model. CLFPR equals to B1 plus B2 CUNR. We can see that CLFPR is linearly related to CUNR. This is known as the functional form of our equation, that is, what is the mathematical function that links the variables together. B1 and B2 are known as the parameters of the linear function. B1 is also known as the intercept. It gives the value of CLFPR when CUNR is 0. B2 is known as the slope. The slope measures the rate of change in CLFPR for a unit change in CUNR, or more generally, the rate of change in the value of the variable on the left-hand side of the equation for a unit change in the value of the variable on the right-hand side. The slope coefficient B2 can be positive if the added worker effect dominates the discouraged worker effect, or it can be negative if the discouraged worker effect dominates the added worker effect. In this case, the scatter diagram suggests a negative relationship. If you look at the scatter diagram earlier, you can see that although the two variables are inversely related, the relationship between them is not perfect, or not exactly linear, because not all of the data points will lie exactly on that straight line. Why don't the 28 data points lie exactly on the straight line as specified by the mathematical model? Remember that our data on labor force and unemployment are non-experimentally collected. That is, we don't have control over the data. Therefore, besides the added and discouraged worker hypothesis, there may be other forces affecting labor force participation decisions. As a result, the observed relationship between CLFPR and CUNR is likely to be imprecise. So the purely mathematical model of the relationship between CLFPR and CUNR earlier is of limited appeal to the econometrician, because such a model assumes an exact or deterministic relationship between the two variables. But in reality, one rarely finds such a neat relationship between economic variables. Most often, the relationships are inexact or statistical in nature. So a more representative model would be an empirical or econometric or statistical model of labor force participation. We can rewrite the equation as CLFPR equals to B1 plus B2 CUNR plus U, where U represents the random error term, or simply the error term. We can let U represent all those other forces besides CUNR that affect CLFPR but are not explicitly introduced in the model, as well as purely random forces. The error term distinguishes econometrics from purely mathematical economics. In our case, we have a linear regression model. In such a model, the variable appearing on the left-hand side of the equation is called the dependent variable, and the variable on the right-hand side is called the independent or explanatory variable. In linear regression analysis, our primary objective is to explain the behavior of the dependent variable in relation to the behavior of one or more explanatory variables, allowing for the fact that the relationship between them is inexact. A word of caution, however, on causality. From our regression model, we have stated that CLFPR is the dependent variable and CUNR is the independent variable. Does that mean that the two variables are causally related? That is CUNR the cause and CLFPR the effect? In other words, does regression imply causation? No, not necessarily. As Kendall and Stewart wrote, a statistical relationship, however strong and however suggestive, can never establish causal connection. Our ideas of causation must come from outside statistics, ultimately from theory. So in our example, it is up to economic theory, that is, the discouraged worker hypothesis, to establish the cause-effect relationship, if any, between the dependent and explanatory variables. If causality cannot be established, it is better to call the relationship a predictive relationship instead. Given our data on the civilian labor force participation rate and the civilian unemployment rate, we can now estimate the parameters of the empirical model by using the method of ordinary least squares. Using OLS, we obtained the following regression results. CLFPR hat equals to 69.4620 minus 0.5814 CUNR. Note that we have CLFPR hat to remind us that this is an estimate of our earlier empirical model. We can see that the estimated value of B1 is approximately 69.5 and B2 is approximately minus 0.58. So how do we interpret them? First, the value of 69.5 suggests that about 69.5% of the civilian working age population will participate in the labor force if there is full employment or zero unemployment. And secondly, the value of minus 0.58 suggests that if the unemployment rate goes up by 1%, ceteris paribus, labor force participation rate is expected to decrease on the average by about 0.58%. In other words, as economic conditions worsen, on average there is a net decrease in the labor force participation rate of about 0.58%, perhaps suggesting that the discouraged worker effect dominates. Now we say on the average because the presence of the error term U is likely to make the relationship somewhat imprecise. Let's take a look at the scatter diagram again. We can see that the points not on the estimated regression line are the actual participation rates, and the vertical distance between them and the points on the regression line are the estimated U's. The estimated U's are called residuals. In short, the estimated regression line gives the relationship between average labor force participation rate and unemployment rate. This next step is basically asking ourselves how adequate is our empirical model and regression line, because we know that there are other factors that affect labor force participation decisions. For instance, hourly wages. They may also attract more workers to the labor market, other things remaining the same. So to see the importance of wages, we collect data on real average hourly earnings as measured by real earnings in 1982 dollars. This new variable is denoted by AHE82 in the third column. So we now have the model CLFPR equals to B1 plus B2 CUNR plus B3 AHE82 plus U. This is an example of a multiple linear regression model, in contrast to the earlier simple two-variable or bivariate linear regression model. Notice that even in the multiple regression, we also include the error term U, because no matter how many explanatory variables we introduce in the model, we cannot fully explain the behavior of the dependent variable. How many variables to introduce in the model is a decision that the researcher will have to make. So now, given all of the data collected, we can now estimate the parameters of the multiple regression model using OLS again. That is, we run another regression. The regression line now becomes CLFPR hat equals to 81.2267 minus 0.6384 CUNR minus 1.4449 AHE82. These results are interesting because both the slope coefficients are negative. The negative coefficient of CUNR suggests that holding the influence of real average hourly earnings constant, a 1% increase in the unemployment rate leads to, on average, about 0.64% decrease in labor force participation rate, perhaps once again supporting the discouraged worker hypothesis. On the other hand, holding the influence of unemployment rate constant an increase in real average hourly earnings of $1 on average leads to about a 1.44% decline in labor force participation rate. While we expected a positive relationship between hourly earnings and labor force participation rate, does this negative coefficient make economic sense? So this is where you apply intuition and try to justify the negative coefficient by going back to theory. You may recall the twin concepts of microeconomics, namely the income effect and the substitution effect. In this example, we skip the diagnostic testing part. So we will proceed with the final step, that is, making interpretations and predictions or forecasts. Having finally settled on a model, we may want to perform hypothesis testing. That is, we may want to find out whether the estimated model makes economic sense and whether the results obtained conform with the underlying theory. For example, the discouraged worker hypothesis postulates a negative relationship between labor force participation and unemployment rate. So from the previous slide, we can see that our regression results seem to be in conformity with this hypothesis because the estimated coefficient of CUNR is negative. In regression analysis, we may be interested not only in estimating the parameters of the regression model, but also in testing certain hypotheses suggested by economic theory as well as prior empirical experience. We can also use our model for prediction or making forecasts. For instance, suppose we have the 2008 data on the unemployment rate and real earnings. Assume these values are 6 and 10 respectively. If we put these values in our regression model, we can get 62.9473% as the predicted value of CLFPR for 2008. That is, if the unemployment rate in 2008 were 6% and the real hourly earnings were $10, the civilian labor force participation rate for 2008 would be about 63%. Of course, when data on CLFPR for 2008 actually becomes available, we can compare the predicted value with the actual value. The discrepancy between the two will represent our prediction error. Naturally, we would like the error to be as small as possible. So, although our example was based on labor economics, I'd like to point out that a similar procedure can also be employed to analyze quantitative relationships between variables in any field of knowledge. As a matter of fact, regression analysis has been used in politics, international relations, psychology, sociology, and many other disciplines. After seeing all of the steps in econometric analysis, let's see how all of that translates into the research methodology chapter for quantitative research. Generally, the research methodology chapter consists of 4 parts: theory, empirical methodology, model specification, and data description. As you can see from the previous example, the first step in econometric analysis is creating a statement of theory, or a hypothesis. Accordingly, the first component in a research methodology chapter is the theory. Theory is absolutely important in research. Without it, we have no base in academic research. Theories are generalizations about the world. They present a systematic way of understanding events, behaviors, and/or situations. So we use theory to guide us in our research on a smaller scale. With research, we can also explore and test parts of theories, or hypotheses. This is because a theoretical model is a simplified description of reality designed to yield hypotheses about human behavior that can be tested. Theory also provides researchers with direction in their research because theories allow us to make links between the abstract and the concrete, and between the theoretical and the empirical. Theories guide us to understand why people behave in a certain way. Theories help us to identify possible factors or information needed to design a particular strategy. They also provide insights into how to develop a solution. Theories can also help researchers to choose variables thought to be related to the research problem. In theories, we have models, frameworks, and basic concepts that direct us to the important questions. So, to summarize, we can see that theories have important roles in research, namely for explanation, prediction, and research guidance. Once we have established which theory or which theoretical framework our research is based on, we need to build the economic modeling from theory. As seen from the previous example, we need to come up with a mathematical model, then the econometric or empirical model, and finally, after tweaks and trial and error, to our regression model. How to do this part is essentially what you have studied in most of your economic or accounting or finance classes. For instance, if you want to know what happens to the price of housing when the population increases, you may use the demand-supply model, where we know that an increase in population leads to an increase in the demand for housing and hence increasing the equilibrium price. Your economic model is how you make predictions of what you expect to find the data. Based on the housing example just now, we would expect to see a positive relationship between housing prices and population, ceteris paribus. Another important point is that your economic model does not necessarily imply a causal relationship between the economic variables. Recall that while you may detect a positive or negative relationship in the data, this alone tells you nothing about which variable is causing a change in the other variable. The economic model can just be used to model this relationship. For the housing example just now, we can assume that in the model, a change in population causes a change in the housing process. Finally, you should use an econometric model that is common in the literature on your subject. Unless you are proposing a new model, you should rely on those used by other researchers in the field already. In other words, use your literature review to justify your choice of model. Here is an example of deriving tourism demand model from demand theory. Why don't you try to derive a model from theory in your own respective field? The second component of the research methodology chapter is empirical methodology. This is where you describe to the reader how you plan to test the relationships implied by your economic or theoretical model. So from the literature, you can identify what are the possible methods. In choosing, you need to see and compare the merits and demerits of all of those methods. Only then will you be able to choose which method is the most appropriate to be adopted for your research problem. Once you have chosen a method, you need to familiarize yourself with that chosen method. Among the things you need to know are what is the data required by the method, what are the property of the data, what is the data frequency, and what is the minimum sample size required. In terms of software, you need to know what are the software or program that can run this kind of analysis. What are the steps in performing this analysis? Do note that learning new methods may take months, as it'll involve running many trial and errors and learning how to make sense of the analysis and results generated, so you need to be patient. Once you have identified which model to use, you need to identify your variables. Variables are the building blocks of quantitative research. First, identify your dependent variable. This is the variable you are seeking to explain the behavior of. Next, identify the possible explanatory or independent variables. Now, these are the variables that could potentially affect your dependent variable. Based on your readings of the literature, you can list down all of the possible independent variables. Finally, you need to be able to justify your choice of independent or explanatory variables. Sometimes you may need to use dummy variables. These are numerical variables that usually represent qualitative attributes of your data that may affect the dependent variable, such as gender, ethnicities, educational level, and marital status. They may also be used to incorporate structural breaks in the model and to capture seasonal patterns in the data. Dummy variables take on the values of 1 or 0. If needed, you need to define your dummy variables. For instance, for gender, you may assign 0 for male and 1 for female. Another example is if we are interested in political affiliation. We can create categorical variables that might assume 3 values: Republican, Democrat, or Independent. We could present political affiliation with 2 dummy variables. Say we take X1 and we say that if it's a 1, they are Republican. So if it's a 0, otherwise. For X2, it's a 1 if they are Democrat and 0 otherwise. So you can see that we don't have to create a dummy variable to represent the independent category, because if X1 is 0 and X2 is also 0, then we know that the voter is neither Republican nor Democrat. Therefore, the voter must be independent. Oftentimes in economic models, there are abstract notions of how some variables affect others. For example, human capital affects production, but how would we measure human capital? You can find suitable proxies for a variable like human capital by familiarizing yourself with the literature. A proxy is a variable that is not in itself directly relevant, but serves in place of an unobservable or immeasurable variable. For a variable to be a good proxy, it must have a close correlation with a variable of interest. From the literature, list down all of the possible proxies for the variable. Then from the list, choose a suitable proxy for the variable and justify the choice of your proxy by looking at data availability and whether or not the proxy suits the context of your study. For most students, the question of which method often comes to mind as well. Here are several tips. Have a discussion with your supervisor or experts and colleagues about your research work. A researcher should be able to provide information to the supervisor and avoid getting information from the supervisor. They should learn and collect many information related to your work to be able to give good feedback. A good supervisor does not provide answers to your questions, but gives appropriate directions to clarify your doubts. Read the latest research papers, relevant theories, and possible application to the present problem and to overcome the difficulties faced. You may also review the methods used by similar research in the past. From the previous slide, you have seen how extensive econometric analysis can be. Therefore, the study of econometrics may provide you with the necessary training in choosing methods, materials, scientific tools, and techniques relevant for your research problem. The appropriate method of study is generated by careful consideration of the research questions. Since there are many methods to consider, you may want to avoid performing trivial analysis. Besides that, it is advisable to use recent techniques instead of outdated methods. Also, keep note, how does your research differ from others? You need to be able to justify the differences. The third component of the research methodology chapter is model specification. This section should include a regression equation, or equations if more than one, a discussion justifying this equation or equations and variables, a description of the expected signs on the coefficients for each of the explanatory variables, that is, are you expecting a positive or a negative relationship according to theory. This section can be placed after economic modeling. You may refer to the comprehensive example in the previous slides on the multiple aspects of model specification, including theoretical foundation, functional form, variables included that are justified by theory, as well as other statistical assumptions. When we have run our regressions, the next step would be to conduct diagnostic testing on our model. Diagnostic tests are a set of procedures that seek to assess the validity of a model in a number of different ways. The usual set of diagnostic tests for quantitative economic research are as follows. To check on the normality of the error term, we use the York-Barrow test. To check for autocorrelation, we use the Durbin-Watson D test or the Bruce-Godfrey-Elem test. To test for heteroscedasticity, we use the White test. To test the functional form or model specification, we use the Ramsey's reset test. To test for stability of the model, we use the Chow test. However, we need to exercise caution when doing the diagnostic tests, as the tests can be different should you adopt different methods. For instance, diagnostic tests for time series regression may not necessarily be the same to panel regression analysis. The fourth component of the research methodology chapter is data description, which basically describes the data you plan to use for your analysis. This section usually includes a citation of the primary source of data, data frequency, how the data are measured, if you have any modifications on the data, and so on. If you are employing secondary data sets, it would be a good idea to decide on the frequency of your data set. Would you want annual data, quarterly, monthly, weekly, or even daily? You also need to decide which type of data is suitable in your study. whether you'd employ a cross-sectional data, or time series, or panel data. It would also be good to think about what sample period is suitable for your study. Would there be any fundamental changes in policy or events during the period? Are there any structural breaks in your data set? This may include changes in exchange rate system, financial liberalization, changes in policy, crisis or oil price shocks. The amount of details you provide in this section depends on the nature of your data. We will look more on data in future video lectures. We end our lecture with this quote by Sullivan. As social researchers, we believe that patterns and regularities occur in society and that these are not simply random. The task we are faced with is to ask why these patterns exist. In other words, to produce explanations of them. We couch these explanations in terms of theories. Theories allow us to select out from a mass of confusing material those elements of reality which are of concern to us. On the basis of theory, we can develop hypotheses about relationships which ought to exist if the theory is valid. Note the highlighted words and phrases. Quantification emphasizes on explanation, answering the question why. Explanation is meaningful only if there are regularities in society. If everything occurs at random, then there's really nothing to explain. If the explanation is logical and is consistent with what has been widely observed, a theory can be built up. For instance, if children from low-income families are observed to perform poorly in class, theories can be advanced to explain why this is so. Theories provide some order to the information we have, but the same information can give rise to different, even competing theories. And theories that work for one group or location may not work for others. Out of a single theory, many hypotheses explaining specific relationships can be postulated. In quantitative research, the primary purpose is to see if hypotheses relating to a particular theory are correct. All this is basically what quantification means in social science.